The Lockheed Martin F-35 Lightning II is a multi-role stealth fighter widely regarded as one of the most sophisticated aircraft ever engineered. Though its maiden flight took place in 2006, the fully operational version didn't enter service until 2015. Yet in less than a decade, it has become a defining icon for military aviation and defense technology followers. In total, the F-35 comes in 3 variants tailored to distinct service needs. One is built for the Air Force, another is optimized for aircraft carrier operations in the Navy and Marine Corps. However, the third version, designed exclusively for the Marines, features one of the jet's signature capabilities: vertical takeoff and landing similar to the Harrier jump jet. By 2044, the U.S. military aims to field nearly 2,500 of these cutting-edge aircraft. The F-35 was engineered for flexibility, enabling it to take on a broad array of missions. One of its most critical tasks is Close Air Support, or CAS. This mission involves striking hostile targets positioned dangerously close to friendly forces. It typically relies on rockets, missiles, precision bombs, and in some cases, strafing runs. Here, an F-35B, the Marine Corps variant, is shown training against simulated ground targets, requiring tight coordination with troops on the ground. These drills are conducted in both daylight and nighttime environments to prepare pilots for real-world conditions. When Lockheed Martin set out to build the world's most advanced fighter, they pursued a rigorous testing program to validate every component. During development, the F-35 underwent an extensive battery of evaluations, including time inside a specialized climatic chamber. This facility subjects the aircraft to extreme temperatures and demanding weather simulations. It helps engineers and test pilots understand how the jet and its systems hold up under the harshest environmental conditions. Throughout these trials, the F-35 remains stationary while replicating multiple flight profiles, including vertical lift operations. Avionics, sensors, and other mission-critical electronics are continuously monitored to ensure reliability from start to finish. Although it can tackle many mission sets, the F-35 is fundamentally designed as a frontline combat asset. To preserve its low observable profile, it carries weapons inside 2 internal bays, each equipped with 4 stations. It also features 2 external hardpoints, capable of supporting up to 2,500 pounds of munitions. Altogether, the jet can deploy a wide mix of missiles, bombs, and other precision weapons. Depending on the loadout, the Lightning can transition between air-to-air and air-to-ground roles almost instantly. Like most modern fighters, it also carries a gun. In this case, a 25mm GAU-22, capable of firing 3,000 rounds per minute. Loading weapons onto an aircraft is a precise and time-intensive process. For this reason, the Air Force regularly holds competitions to identify which ground crew can prepare their jet for launch the fastest. Because individual bombs and missiles can weigh up to 2,000 pounds, ground crews rely on heavy-duty lifts, vehicles, and specialized tools to position them accurately. And although the contest demands speed, crews are still required to follow the same safety and handling standards used for live ordnance. Stealth capability remains one of the F-35's defining advantages. This low observable design is achieved through advanced systems and the aircraft's aerodynamic shaping. The airframe uses what's called a minimized radar cross-section, making it difficult for enemy radar to detect. Its exterior also incorporates radar-absorbent materials that further reduce visibility. To maintain this advantage, pilots rely on the internal weapons bays instead of external pylons whenever possible. An F-35 pilot's helmet takes 2 full days to custom fit, and at nearly $400,000, it's one of the most advanced and most expensive pieces of equipment any fighter pilot will ever wear.
Does it seem like it's too loose there?
Every aviator assigned to fly within the F-35 Lightning family must undergo a rigorous, multi-step helmet fitting process designed for precision and safety. The maneuvers this aircraft demands push pilots to their physical limits, requiring split-second precision while enduring intense G-forces that would overwhelm most people. To perform these demanding missions effectively, pilots must be able to see, hear, and breathe without compromise inside the cockpit. That's why each helmet is individually tailored to the pilot's head using advanced laser scanning combined with meticulous manual adjustments. The price of this helmet reflects not only its complexity, but the fact that it is the most technologically advanced headgear ever built for a combat pilot. The F-35 is also the first fighter jet to feature a helmet-mounted display, or HMD, as its primary interface. When flying above a target, the pilot simply looks down at it, and the system instantly locks the display onto that precise point. This uninterrupted visual interface allows for heightened spatial orientation and more accurate weapons targeting in combat scenarios.
This thing has the ability to take all of the world around it and put it on the pilot's visor, and that gives the pilot the ability to look through the aircraft.
Beyond daytime missions, the HMD is also equipped with advanced night vision, giving the pilot the ability to operate with full visibility even under complete darkness.
That's it.
The fitting process of the F-35 helmet goes beyond optics, ensuring the headgear remains comfortable during hours-long missions.
That's the way to do it.
A correctly sized helmet reduces physical strain on the neck and minimizes pilot fatigue in demanding conditions. By contrast, a helmet that fits poorly can pose serious risks to safety and mission success. The helmet also integrates with the aircraft's most essential survival systems, including the ejection seat, oxygen mask, and onboard communications. A proper fit guarantees these interconnected systems function seamlessly, keeping the pilot safe and mission ready. For countless aspiring aviators, achieving the status of a pilot represents the ultimate realization of their lifelong dreams and ambitions. However, it is important to recognize that stepping into the cockpit is far from a simple or effortless endeavor, demanding an extraordinary level of commitment and perseverance.
The process to become a fighter pilot is pretty long. You go through the academy, which is 4 years, and then you go to pilot training, which is just over a year. And then if you're lucky enough to be selected to go to a fighter, you go to what's called Introduction to Fighter Fundamentals, which is a 2-month course in San Antonio. As then you go to a B course, which is anywhere from about 7 to 9 months long.
Every student pilot must navigate a complex and demanding series of challenges, overcoming numerous hurdles before earning the privilege of commanding an aircraft. Newly recruited pilots are required to endure intensive training programs and a wide array of rigorous exercises designed to prepare them for the high-stakes responsibilities of an operational squadron. Here is an overview of the fundamental requirements and prerequisites that lay the essential groundwork for building a successful career in aviation. Applicants must hold U.S. citizenship as a prerequisite to be considered for entry into the program. A minimum of a bachelor's degree serves as the core educational qualification, ensuring candidates possess a foundation of academic rigor. The field of study may range broadly, encompassing disciplines from aerospace engineering to literature, reflecting the Air Force's recognition of diverse academic backgrounds. The age of eligibility for enrollment begins at 18. With a strict upper limit set at 33 years to ensure physical and cognitive readiness. Candidates are also required to undergo a thorough single-scope background investigation conducted by the U.S. government to verify their history, including financial, educational, and professional activities over the past decade. All prospective pilots must successfully complete both physical and mental evaluations as part of the selection process, ensuring they meet the standards for military aviation. Interestingly, the U.S. Air Force does not enforce rigid, specific physical requirements for pilot eligibility, instead focusing on overall health and aptitude. Becoming an Air Force pilot doesn't require going through the U.S. Air Force Academy. While the Academy commissions many officers each year, most pilots actually come from other paths, like ROTC, or Officer Training School. Reserve Officer Training Corps programs let students attend civilian universities while preparing to serve as officers. For those who already hold a degree, Officer Training School offers a direct route into the Air Force. No matter the path, every aspiring pilot must complete undergraduate pilot training before earning their wings. The F-35 Lightning II cockpit demonstrator is a mobile simulation platform that is primarily used to introduce student pilots to the basic operation and handling of the aircraft. Flight simulators play an indispensable role in pilot training, offering the Air Force a cost-effective and practical solution to replicate real-world flying conditions. Beyond financial savings, simulators provide a safer environment for pilots to practice and refine high-risk maneuvers that would be dangerous to attempt in actual flight. Pilots dedicate extensive hours to mastering the intricacies of aerial combat, particularly the skills required to excel in dogfighting scenarios. Despite the incredible technological capabilities of modern fighter jets, the decisive factor in air combat remains the pilot's skill in executing precise air combat maneuvers. Student pilots receive comprehensive instruction designed to outmaneuver adversaries and achieve a precise target lock under dynamic combat conditions. A critical component of training emphasizes a deep understanding of one's own aircraft, including its turn rates, climb performance, cornering abilities, and thrust-to-weight ratio, which pilots are expected to master thoroughly. Equally important is the knowledge of enemy aircraft capabilities, as understanding adversaries can often determine success in a combat scenario. High-performance pilots routinely endure significant mechanical stress on their bodies during intense air combat maneuvers, which can often result in neck strain and injuries. These strains occur because pilots frequently hold their heads in off-neutral positions while searching for targets or bandits during high-G maneuvers. Managing extreme G-forces is a vital component of a pilot's journey, as exposure to high G loads can dramatically affect both performance and safety. During aggressive aerial maneuvers, pilots can experience forces of up to 9 times their body weight, known as 9Gs, pushing the limits of human endurance. Positive G-forces, which push blood toward the lower body, occur during steep dives or rapid turns, while negative G-forces move blood in the opposite direction, creating unique physiological challenges. During positive G maneuvers, the downward flow of blood can reduce cerebral perfusion, potentially threatening consciousness if the body does not respond effectively. Immediate physiological adjustments are required to maintain blood flow to the upper body, including the brain and eyes, to prevent loss of vision or fainting. The eyes serve as an early warning system, signaling reduced blood flow, and pilots struggling under extreme Gs may experience temporary visual impairment as a result. To prepare for such extreme conditions, pilots train using a human-rated centrifuge, which simulates high G loads in a controlled and measurable environment. The pilot is secured inside a rotating chamber, where centrifugal forces subject them to intense physical stress, while control center personnel monitor vital physiological data and maintain real-time communication. Even the most experienced aviators face challenges in managing spatial disorientation, a condition that can severely affect situational awareness during flight. Another essential tool for pilot training is the altitude chamber, capable of accommodating multiple pilots while simulating the conditions of high-altitude flight. By reducing air pressure within the chamber, pilots experience hypoxia, allowing them to recognize and respond to oxygen deprivation in a controlled setting. This hands-on experience trains pilots to identify early symptoms and physiological responses to hypoxia, knowledge that can prove critical in real-life cabin depressurization events. In real-world emergencies, the final line of defense for a fighter pilot may be ejecting from a malfunctioning aircraft, a procedure that requires precise training and timing. Ejection exposes the pilot to tremendous mechanical forces, An improper technique can result in serious or even fatal injuries to the spine and other vital organs. Following a successful ejection, the pilot must safely deploy a parachute and land securely, which involves mastering lateral drift and water survival techniques. At the Lateral Drift Trainer, student pilots learn how to perform a proper parachute landing. The simulator mimics the sideways motion they might face if they ever have to eject from an aircraft. By practicing controlled landings, trainees reduce the risk of injury when touching down on uneven terrain. This training ensures pilots are prepared to survive safely in the event of an in-flight emergency. By completing comprehensive training in aerial operations, G-load management, hypoxia response, and survival skills, student pilots develop the expertise necessary to become elite guardians of the skies. While other pilots rely on speed and firepower, F-35 aviators master stealth, data fusion, and advanced avionics that set them apart. F-35 pilots typically wear a fire-resistant flight suit paired with their custom helmet as their standard gear. These suits are constructed from advanced materials such as Nomex and Gore-Tex, designed to resist flames while also protecting against extreme elements. Modern versions often include ventilation systems and moisture-wicking features to regulate body temperature during flight.
You're in 8A, it's been code 1.
To climb into the jet, pilots use a lightweight telescopic ladder that is built directly into the aircraft. Before takeoff, pilots follow a strict pre-flight inspection of both the jet's body and its external attachments. For its pilots, every takeoff in the F-35 is a reminder of the power and precision behind the world's most advanced fighter jet. If you're enjoying this content, make sure to subscribe for more videos like this.